Hi everyone, I am Arun JULKA. In Indefinite Integral Part 17, today we will discuss some important questions of integration. Integrate 1 divided by in the root of sine cube x multiplied by sine x plus alpha respect to x. Sine a plus b is sine a cos b plus cos a sine b. We apply this formula in sine x plus alpha. And after that, we'll take common sine x. So now we have dx divided by in root sine raised to power 4x in bracket cos alpha plus sine alpha cot x. When we take sine raised to power 4x common, so we have cosecant square x in numerator divided by in the root of cos alpha plus sine alpha cot x respect to x. Now we put cos alpha plus sine alpha cot x equals to t. Differentiate respect to x both sides and we'll get derivative of cos alpha is 0, sine alpha as it is, and derivative of cot x is minus cosecant square x equals to dt by dx. So cosecant square x dx equals to minus dt by sine alpha. Replace cosecant square x dx by minus dt by sine alpha and cos alpha plus sine alpha cot x by t, and after integration we'll get the answer minus 1 by sine alpha multiplied by 2 root t plus c, and the value of t is cos alpha plus sine alpha cot x. Next question, integrate in root of x square plus 1 in bracket log x square plus 1 minus 2 log x divided by x raised to power 4 respect to x. We can rewrite this question. Integrate in the root of x square plus 1 divided by x multiplied by 1 by x cube. We just x to the power 4 in two parts, x into x cube. Now in bracket we have log x square plus 1 minus log x square, because n log m is log m to the power n. And the formula of log m minus log n is log m upon n. Now we have in the root of x square plus 1 divided by x square into 1 by x cube log x square plus 1 divided by x square respect to x. It is 1 by x cube in root of 1 plus 1 by x square log in bracket 1 plus 1 by x square respect to x. Now we put 1 plus 1 by x square equals to t, and when we differentiate respect to x, both sides will get minus 2 by x cube equals to dt by dx. So dx upon x cube equals to minus dt by 2. Replace 1 by x cube dx with minus 1 by 2 dt and 1 plus 1 by x square with t. Now take log t as a first function and root t as a second function, solved by y parts. First function as it is, integration second is t raised to power 3 by 2 upon 3 by 2 minus derivative first is 1 by t, integration second is t raised to power 3 by 2 upon 3 by 2. And when we integrate second part, we will get t raised to power 3 by 2 upon 3 by 2 whole square. And after simplification, we will get the answer minus 1 by 3 in bracket 1 plus 1 by x square whole raised to power 3 by 2 log in bracket 1 plus 1 by x square plus 2 by 9 in bracket 1 plus 1 by x square whole raised to power 3 by 2 plus c. Next, integrate root x dx divided by in root of a cube minus x cube respect to x. We can rewrite this way, root x dx divided by a raised to power 3 by 2 whole square minus 3x raised to power 3 by 2 whole square in root. Now you put x raised to power 3 by 2 equals to t, and when we differentiate respect to x, both sides will get 3 by 2 root x equals to dt by dx. So root x dx equals to 2 by 3 dt. Now replace root x dx by 2 by 3 dt and x raised to power 3 by 2 by t, and the formula of 1 upon the root of a square minus x square is sine inverse x upon a. So it is sine inverse t upon a raised to power 3 by 2 plus c, and the value of t is x to the power 3 by 2. So the answer is 2 by 3 sine inverse x upon a whole raised to power 3 by 2 plus c. Next example, integrate in root of 1 plus x squared divided by x respect to x. Here we put root 1 plus x square equals to t. Squaring both sides and we will get 1 plus x square equals to t square. So x square equals to t square minus 1. Differentiate respect to x both sides and we will get 2x dx equals to 2t dt. 2 cancel by 2, so x dx equals to t dt. Now divide by x square both sides and we will get dx upon x equals to t dt divided by x square, and the value of x square is t square minus 1. So dx upon x replaced by t dt divided by t square minus 1, and the 1 plus x square replaced by t. And after simplification we have t square divided by t square minus 1. When we divide this fraction we will get 1 plus 1 upon t square minus 1 dt, and when we integrate this we will get t plus half log in mod t minus 1 upon t plus 1 plus c. Replace t by in the root of 1 plus x square, and the final answer is in the root of 1 plus x square plus 1 by 2 log in mod in the root of 1 plus x square minus 1 divided by in the root of 1 plus x square plus 1 plus c. In this question we use formula dx divided by x square minus a square is 1 upon 2a log x minus a upon x plus a plus c. Next question, integrate cos square x divided by cos square x plus 4 sin square x respect to x. First we convert full question into form of cos square x. So replace sin square x by 1 minus cos square x. So now we have cos square x dx divided by cos square x plus 4 in bracket 1 minus cos square x, and after simplification we will get cos square x dx divided by 4 minus 3 cos square x. Now divide and multiply by minus 3. Now we have minus 1 by 3 outside, minus 3 cos square x dx divided by 4 minus 3 cos square x. Now add 4 and subtract 4 in numerator, and now we have minus 1 by 3 outside, 4 minus 3 cos square x minus 4 divided by 4 minus 3 cos square x dx. Now when we divide into two parts we have minus 1 by 3 integration of 1 respect to x, then plus 4 by 3 dx divided by 4 minus 3 cos square x. In second part divide numerator and denominator both by cos square x, and we will get sec square x dx in numerator divided by 4 sec square x minus 3, and now convert sec square x into 1 plus 10 square x in denominator. So we have minus x by 3 plus 4 by 3 sec square x dx divided by 4 in bracket 1 plus 10 square x minus 3. Now put 10x equals to t, differentiate respect to x both side. So sec square x equals to dt by dx, so sec square x dx equals to dt. Replace sec square x dx by dt and 10x by t, and after simplification we have minus x by 3 plus 4 by 3 dt divided by 1 plus 4t square minus x by 3 as it is. In the second part take 4 common, so we have dt divided by 1 by 4 which is 1 by 2 whole square plus t square, and the formula of dt upon a square plus t square is 1 upon a tan inverse t upon a. A is 1 by 2, and after simplification and put the value of t, we will get the answer minus x by 3 plus 2 by 3 tan inverse 2 tan x plus c. Next example, integrate sin inverse root x minus cos inverse root x divided by sin inverse root x plus cos inverse root x respect to x. We know that sin inverse x plus cos inverse x equals to pi by 2, or we can say that cos inverse x equals to pi by 2 minus sin inverse x. So now we have sin inverse root x minus in bracket pi by 2 minus sin inverse root x whole divided by pi by 2, and now we integrate respect to x. So we have 2 by pi outside the integration and 2 sin inverse root x minus pi by 2 respect to x, and after simplification we will get 4 by pi integration of sin inverse root x respect to x minus integration of 1 respect to x, and we can write this way 4 pi I1 minus x plus c, where I1 denote sin inverse root x. Now we solve this question separately. I1 is sin inverse root x, is a question of inverse. Now we put root x equals to sin theta. So x equal to sin square theta. Differentiate respect to theta both side and we will get dx upon d theta equals to 2 sine theta cos theta. It's the formula of sine 2 theta. So dx equals to sine 2 theta d theta. Sine inverse root x replaced by theta and dx replaced by sine 2 theta d theta. Now we'll solve by parts, taking theta as first function and sine 2 theta as second function. First function as it is integration second, minus derivative first, then integration second. In second part, we'll again integrate and we'll get minus theta cos 2 theta by 2 plus 1 by 2 outside sine 2 theta by 2 plus c. Now we'll replace cos 2 theta by 1 minus 2 sine square theta, and sine 2 theta is 2 sine theta cos theta, where cos theta is in the root of 1 minus sine square theta. Now theta is sine inverse root x and sine theta is x, and put in first we'll get answer 4 by pi in bracket 2x minus 1 sine inverse root x plus 1 by 2 in root x minus x square minus x plus c. Last example, integrate e raised to power sin x in bracket x cos cube x minus sin x whole divided by cos square x respect to x. We'll divide this question into two parts and we'll get e raised to power sin x into x cos x minus e raised to power sin x sec x tan x. In the first question, we'll take x as a first function and e raised to power sin x into cos x as second function and solve by parts. First function as it is integration second, minus derivative first and integration second. In the second part, we'll take e raised to power sin x as first function and sec x tan x as second function and solve by parts. And after simplification, we'll get x e raised to power sin x minus integration of e raised to power sin x dx minus e raised to power sin x sec x plus e raised to power sin x dx. Now e raised to power sin x dx cancelled by e raised to power sin x dx, and after simplifying we'll get the answer e raised to power sin x in bracket x minus sec x plus c.